Actually grab a clean sheet. Here you go. All right. So basically on these graphs, what we're seeing, how many of you guys remember seeing these graphs like in biology or some of you? Maybe, or when you were learning about enzymes, possibly? Yeah, that's usually when those graphs come out, or photosynthesis, cellular respiration, because we talk about endo, exo. All right, so anyway, so a couple things to notice on these graphs, because again, this is not difficult, but you got to know which pieces to pay attention to. All right, so the first thing we notice is these both are representing two different reactions, right? And we saw in the notes portion, exothermic means that it's releasing energy. Endothermic means it's absorbing energy, right? So now let's look at what the graphs look like. So they both have this little hill-looking thing, right? So it's like you go up a ladder, you slide down a slide. That's what usually people say, all right? So if you notice, this slide is a whole lot shorter than, I'm sorry, the ladder is a whole lot shorter than on this side, right? So that has to do with our activation energy. How much energy do you have to put in to make it to this point up here called my activated complex? So an activated complex, that is the point, that is the energy button that you need to push in order to make a reaction just go. Okay? So you have to reach this spot in order for that chemical reaction to even occur. Okay? That's your activated complex. Now, the amount of energy it takes to get there is what's different for these, right? Exo versus endo. You start at different places. You have a high reactant, low reactant. And then you end up finishing either low or finishing high. So that's going to be the part that we're going to focus in on here. So for exothermic, we're going to go ahead and say that energy of my reactants is greater than of my product energy. For my endothermic, the opposite is true. My reactants are less than my product energy, meaning I'm going to gain energy in that process. We're only paying attention to where we start and where we finish. That right there, that's thermo. This middle part, that more has to do with biology. It has to do with kinetics. It has to do with knowing about catalysts and things like that. We still will talk about it, but for thermo, we really just pay attention to the beginning and end. It's called a state function, okay? All right, so activation energy, we're kind of seeing you're going to get from taking your top of this little graph minus wherever we're starting. That makes sense, right? Final minus initial. There's that idea again. Here, final minus initial. So a lot of activation energy, a little activation energy, okay? Activation energy you can think of like dominoes. If you set up a ton of dominoes and they're doing that cool little thing around a room, you have to push the first domino. It's not going to start on its own, correct? You have to put the energy in there. You have to get it to go, and then it's going to go on its own, all right? That's called spontaneous. Sorry. Spontaneous would be if it does it on its own without energy being inputted. Okay, so the next thing that I would put on your page is we're going to go ahead and say reactants. I'm just going to put R if that's cool with everybody. Reactants, arrow, there we go. Reactants yield product plus energy in kilojoules. Meaning I could have my A plus B yields AB plus 5 kilojoules. All right, so it's meaning that energy is a product over here. For an endothermic reaction, we would have reactants plus that energy. So it's another way to recognize if we have endo and exo. So the point of all this is I need you guys to be able to recognize if we have an endothermic or an exothermic reaction, okay? Is it being released or is it being absorbed? So here we would have a reactant with some energy because it needs the energy to keep going, right? Makes our product. Nothing in the products, okay? We're ending higher. The last way to recognize these is talking about that heat. So if this is letting out heat, would you say that's going to be a negative Q or a positive Q? Think about that. Negative, because think about it. If you end up with a lower temperature, right, you're doing low minus high. That's a negative number, negative Q value. So negative Q, go ahead and put a negative delta H. You don't know what that is yet. We're going to talk about it in just a second. For endothermic, we're going to be looking for things that have a positive Q, absorbing energy, and a positive change in enthalpy, which is the same thing as heat. Okay. All right. So we talked about that. We talked about, here's our delta H. We're going to talk about that. It's talking about start to finish. That's all that you're paying attention to. Don't worry about the bumps. If you do need to know, so in biology, your enzymes, what did the enzymes actually do? What was the point of learning about enzymes? Does anybody remember? It did, yeah, so it kind of got the reaction to go. So you guys probably had an enzyme lab or something where you had yeast and you had to collect bubbles. Do you guys remember doing that? No? Like collecting carbon dioxide? No. Okay, all right, that's okay. That's okay. Maybe I'll get that stuff out. But an enzyme, essentially, what I was expecting to hear was that it speeds it up. So enzymes we think of as speeding up a reaction. It doesn't mean it pushes it along. What it does is it takes this activated complex and it brings it lower, which means it doesn't need as much energy. It doesn't need as much time in order to get going. Okay? And that's how it speeds up. Okay. All right. Everything else, all the details are here, so I'm not going to be asking you to write too much. I'm just going to say, okay, exothermic products have less energy. Endothermic products have more energy. Right? Easy enough. Activation energy, please put a star next to that. So activation energy, I usually show with EA. That's usually how you would see it. Okay, so activation energy. And the difference in energy from the reactants to the activated complex. So what that means is that we're going to take our activated complex and we're going to subtract our energy of reactant. Okay? Meaning we're going to take the top, we're going to subtract where it starts. Top, subtract where it starts. Make sense? So you're getting that EA that you see on both of these. So it's all final minus initial. All right. Delta H, change in enthalpy or heat of the reaction. The energy lost or gained, right? So that means delta H is Q. So if we can solve for Q using calorimetry, we can then essentially bring it over to a graph like this and get a little bit more information because there's actually a lot more formulas. We're not going to learn all of them, but you can definitely focus in on the being exothermic or endothermic, right? So the equation that you see here, you will be asked to do that. All that you're doing, looking at a graph, you're going to take your products minus your reactants. Okay, products minus the reactants. Heat of the products means the energy in your products. So we usually put E with a little p. Heat of the reactants, we're going to have E with the reactants. Okay? Activated complex, the only thing I would put there is it's the top of the bump on that graph. Okay, all right, so just to make sure you've got it real quick, looking at this diagram A, what is the heat of my reactants? What is the energy on my reactants according to your graph? Well, look at there's actually a number that goes with it now. 30. It's 30, so I'm just going to write it right there. So we have 30 there. What's the product? 10. So could you technically find me delta H? Do product minus reactant. Okay, so 10 minus 30 gave me negative 20. That's what I heard you guys say, kilojoules, right? So what that means, what does that mean? Is it endo or exothermic? Does it exit or does it enter? Exothermic, all right? So this is exothermic. We also can see that it's exothermic because my reactants are a whole lot they're a whole lot higher than my products, right? My reactants are definitely greater than my products. You guys see that? So different ways to see which one is endo and exo, all right? Those are some of your answers down here. Your activated complex, what's the value for that? That's just reading your graph again. What is my activated complex? Good. So that is going to be 40. The only other thing I would add to this is just saying that this would mean that energy is a product, right? It's being released. So 20 kilojoules of energy are being released. Okay. So we'll come back to these questions later. For right now, go ahead and get out your Schoology assignment. And if you needed to copy down any of this, you can definitely do that. I know I kind of went a little quick there at the end. On Schoology, you should have, so the assignment from yesterday, I went ahead and changed the due date to today just so it will still show up to remind you. But if you didn't finish that, you want to finish that one. And then there is one that has the graphs and the calculation thing. Pretty simple. It's not too bad. All right. But the rest of the time is for you guys to do that.